Hello, I welcome you all to this another interesting screencast. The problem reads, locate the centroid X bar and Y bar of the area. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Alright, we have been asked to locate the centroid of an area. So before I start solving this particular problem, let's talk a little bit about what centroids are. So what is centroid? So centroid, can think of centroid as the geometric center of an area, geometric center of a line, a geometric center of volume. All right. So we have what is called centroid of a line. We have centroid of an area. Okay. We also have centroid of volume of a volume. Okay. So centroid of volume, right? All right. So when the density is uniform, the centroid coincides with the center of mass. And when the gravitational field is uniform, then the centroid coincides with the center of gravity. Okay, so this is basically about it. So we want now to start solving. To start with, we are going to start with the centroid along the x-axis. We are calling it x bar. So what we are going to do is we are going to cut a small area in this direction like this. Think of this as a small strip. Okay, there we go. Okay, and this strip has some thickness. It has some thickness dx. All right. It has some thickness dx. All right. And once we've done the cutting of that particular area, we'll need to name it. This small strip, it will have its own centroidal axis. Okay, so this point here is the starting point, the reference. So from there to that point where we've cut the strip, this is this centroid axis in the x direction. So x curled for the centroid axis in the centroid location in the x-axis, this is going to be equal to just x. Okay, right? And then is going to have, then this whole height there from there to there is y. Then its centroid position in the y-axis, it will be the midspan. This position here is equal to this one there is equal to y curled is equal to y divided by 2. Alright, so we've cut a strip which later on we are going to integrate that. By integrating, we are going to expand this. In our case, we'll expand it in the x direction. So it's like we're going to expand it like so, which is integrating so that it fills up this area here. Okay, this is basically what we want to do when we're integrating. Okay, so once we've done that, then now this particular small strip, it will have its own area that we are calling a small area dA, and this dA is equal to the dimension, because think of this strip as a very small rectangle. All right, so it has a height of of y, and it has a thickness of dx. So this is the area for this small strip. All right, and then once we have this information, then we also know what y is. We've already been given y itself is equal to h divided by b squared times x squared. Then we know that x bar is equal to the integral. So since we are integrating with respect to dx, so we are going to get the limits or the boundaries along the x axis. So it is from 0 to b. Okay, and then we have the x curved, which is the centroidal location of the small strip in the x direction, and then the a divided by integral from 0 to b dA. So when you look at this, what we are basically doing here is just taking moments of areas. We are equating moments of areas, and then we make x bar subject of the formula, right? Yes. So let's now replace what we've already found. Integral from 0 to b. X bar, we said, is just x. And then dA, we said it is y. It's y times dx, right? It's y dx. Remember this? Divided by 0 to b y dx. Okay, so we are going to replace this y. We replace this y with h. We replace this y with this particular equation. Therefore, we're going to have x bar is equal to integral 0 to b, then x times h divided by b squared, then x squared dx divided by 0 to b h divided by b squared x squared dx. Then finally, if we did the integration, we're going to have, since x by x squared is x cubed, integrating x cubed, we have, let me factor out the h over b squared, and then this becomes x to the power 4 divided by 4, right? We are integrating from 0 to b, divided by, at the bottom we'll have h divided by b squared, x cubed divided by 3. Okay, and then finally we have x bar is equal to h divided by b squared, okay, then by, this just becomes b to the power 4 divided by 4, and then h divided by b squared, then this becomes also b times b cubed divided by 3. So this and this goes, b1 there, go there, we just remain with a b. Therefore our x bar is finally going to be equal to a 3 quarters of b. Okay, so this is the solution for the first part of the problem. All right, this is the solution for the first part of the problem. So we need to move to the second part, which is locating the y bar. So what we are saying is the centroid location in the x-axis is 3 quarters of b. 3 quarters of b from this point. So if we are to show it here, we are saying it is somewhere there like that. So this one is 3 quarters of b. Okay, this is where it is, somewhere there like this. All right, so this is about it. So let's move on to the next stage. I'll need to wrap this, and then so that I draw another strip, but this time around in the y direction. Okay, all right, is that fine? Great. So there we go. Let's draw another strip. This time around we are on this, locating a centroid y bar of the area. Okay, so let's draw another strip like so in this direction. There we go. So we have this strip, and this strip, it has a thickness dy. Okay, it has a thickness dy. Again, think of this as a very small rectangle. Okay, it will have also its own centroidal locations, all right, that we are defining by x curved and y curved. All right, so let's name those. Since the thickness of this particular strip dy is so small, like it was in the other case, therefore its centroid location in the y-axis will be y curved is just equal to y. Okay, and then this location here is going to be equal to this is just going to be equal to x. Okay, and if this is the case, therefore this whole length here is going to be equal to, this length is going to be equal to, I can write it inside here, it will be equal to b, because the whole length of this is b, so it's b minus x. All right, and then what is centroid location in the x-axis? This centroid location in the x-axis will be the following. Let me show it here. To be the following. So this is going to be its location in the x-axis. So it will be x squared is equal to x, which is this one, okay, plus b minus x divided by 2. Does it make sense? It does. Great. Okay, so now we can simplify this further. So therefore our x bar, if we simplified it further, our x bar therefore becomes equal to, we want to simplify this part here, okay, all right, sum it up and so on. Then we are going to have x, plus x plus b divided by 2, right? Of course. So we have all that information. So what we need to do now again is to start working. All right. So what is our dA for this one? What's our dA? Let me draw just a boundary here. Our dA for this new case here is, our dA, our small area, is going to be equal to its length, which is b minus x, then times this thickness, which is dy. Is that fine? It is. Great. And then we know that y is equal to h divided by b squared, x squared. We can make x subject to the formula because we'll need to replace this x, because we are going to be integrating with respect to y, so everything else must be y. So rewriting this, it becomes x equal to, making x subject to the formula, we are going to have square root of b squared divided by h times y. All right, everything else is in that square root. Of course, you expect a plus or minus, but for us, we are just going to use the positive value. All right, just a positive value. Okay, so then we know the formula for y bar. Y bar is equal to integral. This time around we are integrating with respect to dy, so the boundary conditions is from 0 to h, y cubed, which is the centroid location of the strip, the small strip that we did, dA, then divided by integral from 0 to h dA. So we replace the values in there. This y bar is going to be equal to 0 to h. Y bar, we said, is just y. And then dA, we said, is b minus x, and then dy. Divided by integral from 0 to h is just b minus x dy. Great. So quickly we replace what we already know what x is. So this gives us y. We have y bar, therefore it's going to be equal to 0 to h. 0 to h. We have the y. There we go. Then we have b minus, we said what is our x? We said our x is equal to root of b squared over h times y, right? So this therefore becomes equal to, we can write this as equal to, let's replace the x there. It becomes equal to root of b squared divided by h times y. Okay, and then we have a dy. Okay, we do the same at the bottom there, 0 to h. There it has b, of course, minus square root of b squared divided by h times the y, of course, dy. We can expand this further on. If we expand this, then it becomes integral from 0 to h. We have yb by minus root of b squared over h times y, maybe to the power half. If I wanted to convert it like that, I move it inside. And the y, there is another y there, sorry. This y is multiplying, there is this y. So once it multiplies, then that changes, it becomes a 3 over 2, right? You've seen this y here. So we are talking of y times y to the power half, which is equal to just y 3 over 2. This is where this came from. Okay, this y and the other y there. All right, great. So once we have that, then dy, then also the same thing at the bottom there, from 0 to h. 0 to h, there we only have a b. Then minus root of b squared over h, then y to the power half dy. So if we were to do the integration, okay, b by y squared divided by 2 minus 2 root b squared over h, and then we have y 5 over 2 divided by 5. Okay, from 0 to h, then divided by, then we have by minus minus 2 root of b squared over h. Then we have y to the power 3 over 2. This one divided by 3. All right, let me great. Then once we've done everything else, we should be able to arrive at the final solution, which is 3 over 10 h. Okay, so this is the final solution for y bar, all right, which is from there somewhere to just somewhere there. Okay, if I was to show this here, to just somewhere there. So this is our 3/10 h. Okay, great. I think this is about it. And then we have at the bottom there, what did we find? We found something like this one, which is our x bar, which is 3/4b. Okay. This is our x bar. This is our y bar. All right. I think this is about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.